Hi everyone, welcome to MOSFET. So you can see one circuit is drawn here and we have to find out the small signal gain for this circuit. Now if you see carefully this circuit, you will observe input is being applied at the gate of this MOSFET M1, whereas output is being taken from the drain of this MOS. So this particular MOS M1 is working as a common source amplifier. Whatever extra circuit is added, that is basically changing the gate voltage. So we will consider this circuit while analyzing the potential and all. But if you start looking the circuit carefully, this is a common source amplifier, and we know for common source amplifier the small signal gain can be given by minus of gm into r out. So we need to find this AV gain, the small signal gain for the circuit. So we need to find these two individual parameters, GM and R out. Once we will have the value of GM and R out, we can multiply these two parameters and we will have a small signal gain. Now one way of solving this question is by drawing a small signal model of this circuit, and then we can also calculate the small signal gain, but that's a very exhausting way of doing the thing. So rather we will focus on finding GM and R out and we will just multiply this thing. So let's start with the calculation of R out because that's the easier one for the circuit. So if we have to calculate R out, so R out basically the output resistance from this node because that's where we are considering V out. So if you look at this particular node, two resistors are there. One you can directly see RL load resistance, which is connected between supply and your output voltage. So R out will have one component of RL, and from the other component of resistance will come when we start looking the resistance from this drain node of MOS M1. So if we look from drain into the MOS M1, the impedance of this MOS will come R0. So that will be in parallel with the load resistance RL. So overall R out you will get RL load resistance parallel to R out. In general, R0 value is considered very high. So if we take the parallel combination of RL and R0, so we will get R out equal to RL because in parallel combination, whatever quantity will be the lesser, that will dominate. So that's the first part of the answer which we have obtained. R out we know now. Second thing which we need to find out is transconductance GM. So for any MOSFET, we know, let's consider one single NMOS or PMOS. If we have to calculate GM for this, so that GM can be defined by change in the ID current with respect to change in the VGS voltage. This is GM, right? If you look at this MOS M2, similar thing we can obtain here also. For this MOS M1, GM will be defined by change in output voltage, that is I out. We are assuming I out is flowing from this load resistance, divided by change in VGS of this MOS. Now, source voltage is ground for this MOS. So ultimately we have to find out VG here, gate potential. Vn is being applied here, but there are other circuits also in this whole structure which will change this gate potential. So we need to find out VG. Once we will know the VG, we can easily calculate this GM potential. We can easily calculate GM value. So in order to calculate this VG potential, we need to see what values are coming into the picture. So if you start looking from this node, input impedance is infinite, gate impedance is usually infinite for an ideal MOS. Now, small signal analysis when we do at high frequency, so this capacitor will be considered as a short, so only RS will come here in this part. Along with that, this RA and RB will be in parallel, so these two combined, we can write it as RA parallel to RB and one more resistance. So if we start looking from this particular node, gate and drain are shorted. So when we start looking the impedance from drain side, we will get 1 upon GM for this diode connected load. So this resistance would be 1 upon GM. So ultimately, if you see the total resistance for this upper path, we will get RA parallel RB, which will come in series to 1 upon GM. So this is the total impedance which we will get for this network, the topmost network, and here we are getting RB. So if I simplify this whole structure, it will look something like this. So this is the gate potential which we need to calculate. This is Rs, and this impedance, let's call this as A. This represents this value, Ra parallel Rb, which is in series with 1 upon Gm. So we need to calculate Vg. So it's a classic case of resistance divider circuit. So if I have to calculate Vg, I can write it as Ra parallel to Rb, this in series with 1 upon Gm, divided by, again, this whole structure of Ra parallel Rb plus 1 upon Gm plus Rs into Vin. This is the value of gate potential we will get here. Now we know the VGS for this MOS, because source potential is 0, so this will become our VGS also. If I subtract 0 from here, so this would be our VGS also, right? Now if I have to calculate I0, so that would be equal to Gm into VGS. Now if you see VGS we already have calculated. If we multiply Gm in this, so we will get I0. So let's multiply here in this parameter Gm value. So I have multiplied here Gm so that this will become I0 value. Now if you see, we already know that if we do I0 divided by V, we will get the capital Gm of this circuit. This needs correction. This should be V in. So we now have I0 divided by V in we can do. So if we divide this I0 by V, we will get capital Gm value. So this whole value is of capital Gm. Now it's become easier for us. We need to find out gain AV. So that would be equal to minus of this parameter Gm into R out. So let's write this. So Gm into Ra parallel Rb plus 1 upon Gm divided by Ra parallel Rb plus 1 upon Gm plus Rs. This will get multiplied with RL, which is R out. So this is the small signal gain which we will get for this question. So important part here was to calculate the transconductance value and the value of R out. After that it's only about the multiplication. So I hope something new you might have learned from this video. If you found this video useful, please share with your friends. And if you haven't subscribed to our channel, please do subscribe.